This video tutorial will provide a summary and outline of how to use the latest Adapt Integration Console version 5. And specific to this tutorial, we're going to talk mainly about Etabs version 2016, where we use the API to extract an Etabs model both from a geometry standpoint and also for applied loads and reactions. The same methodology applies also to Etabs version 2015. Notice we also have the old integration console format through use of input-output reports for Etabs version 9 and also import and export for STAAD Pro. So we're going to focus again on Etabs 2016. And before we move forward in extracting and loading the Etabs model, we want to just review what Etabs model we're going to use here. So we'll go ahead and we'll just cancel that for just one moment. And we're going to launch Etabs to show the model that we'll be importing into Builder. So in Etabs version 2016, we have a multi-story concrete frame, has walls, columns, and slabs. And just to quickly summarize this model, under the define options in this program, we can go to load patterns. We can see that we have both dead and live loads. These are gravity loads plus self-weight, EQX, EQY, WindX, and WindY, both seismic and wind lateral forces on this particular structure. The structure has been solved. These are linear static lateral loads, and we've solved the analysis inside of Etabs. So we'll go ahead and just close that, and we're also going to go back to our integration console. Again, using Etabs 2016. We'll first load the model. So we need to select which model it is we want to load into our integration console. And I'll go ahead and select this model that I just had opened. And I'm also going to go ahead now and select the option for load the model. This requires an active Etabs license. So if there's no license available, Etabs will report back that the program could not be opened. You have to have an active license in order to load the model for the API to be accessed and used. Once the model has been loaded, we can then determine what the import options are that we're going to use. So by just loading that model, we can import the geometry and also the reactions for any load cases that have been solved in Etabs. If we want to also apply the story forces for lateral loads, we have to access and have available the XML file that writes the story forces to that file. So in this case, I'm going to also import our applied lateral forces. I'll select that checkbox and I'll go back to Browse. I've created an XML file in Etabs for story forces. So this XML file is saved here. I'll go ahead and just select that. That loads the XML file containing that information. You can also choose which levels to import. If you want to import the entire model, we would select all levels. If we wanted to import only a specific level, we can go and scroll and select just that level. This is useful, for example, if we want to import the lowest level of an Etabs model and bring in the wall and column reactions for purposes of building a mat or a foundation model inside of Adapt Builder. And then we would have the ability to import the loads onto the mat, process the analysis and the design of the mat in Adapt Mat, or also Adapt Floor Pro if you're doing a transfer slab. So we'll go ahead in this example and use all of our levels. We want to import the entire structure, all the geometry, the applied gravity and lateral loads, and also the reactions. We'll go ahead now and we're going to create an Adapt Exchange file. This is a .imp file that we'll create. Once the IMP file has been created, we'll return a message shown here that it's been done successfully, and we can just select OK and close now the windows for the integration console. If we navigate over to the folder where we locate our Etabs files, we can see that the IMP is generated and selected and placed in the folder where the Etabs model stems from. So we have an IMP file here that we're going to now access inside of Builder. This latest version of the integration console is compatible with the latest version of Builder 2016 Build 3. So make sure that if you're using this console, you have this version installed on your computer. We'll go ahead and launch Builder. We're going to use Edge and also Floor Pro in this example as our selections when we launch Builder. And inside of Builder, we're going to select File. We're going to import generic adapt file. And I'll select the IMP file that was generated and placed in my Etabs folder. And we'll go ahead and select that. Our import options dialog is going to open. Now we have the ability to import the entire structure or specific levels that might be included in that structure. And at the very bottom you can see we want to import a specific level. These are the levels taken out of Etabs. If I want to import the entire structure, I'll just select all. That's going to then increase the count here that shows beams, columns, etc. All of the components that are going to be created inside of Builder. Notice that they're grayed out. If we import the entire model, then everything will be imported in. If I import just one level, the user has the ability now to sort and filter the types of components that can be imported into Builder. We'll go to the Load and Load Cases menu. These are the load cases that are now being imported into our structure. So the load case name is shown here. We have gravity and lateral loads. The type of load that was defined in Etabs can be defined here, and we can modify that. For example, I can change this to gravity, static lateral, non-static lateral, and so on. We have the ability to determine if we want to import only the applied forces and reactions, reactions only, or nothing. We don't have to import any of the applied forces or reactions if we select no. We also can map these load cases to a specific name that's been created inside of the Builder model. So by default in the Builder model we have dead load, live load, self-weight, pre-stressing, and hyperstatic set up, and we can map these loads to loads that are shown here. If we had created different load cases inside of the Builder model prior to importing the Etabs model, those would also be listed. We're going to go to load combinations, and we can see we have several combinations that are also being imported in. We can select to import all of these or none of these, and that just changes the tag here for import to yes or no. We'll go ahead now and select OK. And on screen we can see that the Etabs model has now been converted to a Builder model. I'll go ahead and rotate the model to a three-dimensional view, and you can see there's several loads that are shown. These are the gravity loads being shown. If I go to the loads dialog menu for the selection and select set view items, you can see these are represented as patch loads. This is dead and live, and those are the loads that were imported from Etabs. I'll go ahead and turn those off. We also have wind and seismic loads that were imported, and the wind and the seismic loads, because they're lateral loads set up in Etabs, they're imported as applied lateral forces inside of Builder. So if we go to the option for loading, add load, and I go to the lateral load, generic lateral load wizard, you can see that under the update existing load case name we have several load cases here. We have EQX, EQY, WindX, and WindY. And for each of these load cases our program will write the direction that the load is applied in and also write in the story forces. So we can technically now take the load cases created in Etabs, they're written into Builder, and we can analyze for these story forces inside of Builder if we wish to do that. So these will provide us with those different story forces and directions for lateral loads. From loading load case library, we can see that under the building load tab we have EQX, EQY, WindX, WinY as building loads. That means inside of Builder they have to be solved for in full structure or global mode. They can't be solved for in single level mode. And then we also have the dead and live loads here that were imported. There's also this modal load. There was no loading assigned to that in Etabs. It came in because it was a defined load case name. But these are the two load cases that have loads actually assigned to them. It's also important to note that we imported the reactions from Etabs. So we haven't analyzed or meshed or done anything yet with the builder model other than import the builder model in, but along with the import are the reactions in the walls and the columns. If I turn on the result display settings inside of Builder, you can see that for the load case options we have load case results, and those results are all Etabs results. So for dead, EQX, EQY, live, modal, WindX, WinY, we have the tag Etabs, meaning the results stem from that program and they stem from a global analysis in Etabs. For example, if I turn on EQX and I navigate down to my column branch under Actions Load Case, I'll go ahead and stretch that out a little bit so we can see the column setting. The load case actions, if I turn on axial and I look at these column actions, these forces in the columns are the forces that were taken from the analysis out of Etabs into Builder. And the purpose of this would be if you wanted to run a single level analysis inside of Builder, we can include the end reactions in the columns or walls to combine that with gravity reactions or gravity loads that might be native to Builder to combine a gravity and lateral solution from two different programs. It's not required that you do that. You can always analyze a structure for lateral and gravity within Builder, but that is a possibility. That's one reason you would bring in reactions from Etabs through the integration console. And you can see we have shears in both directions. I'll go ahead and go to single level so we can see that a little bit better. So we have the shear forces and also moments C1. Let's say we wanted to run this single level analysis with the reactions brought in from Etabs. I'll go ahead and first I need to mesh the slab, so I'll go to FEM Automatic Mesh and I'll mesh this single level, and then I'll go to FEM Analyze Structure, and we can see that the load combinations that were imported from Etabs have several combinations that include, let's just say EQX, EQY, and so on. So if I select a couple of these that include EQX and also EQY, we'll do 4 combinations. We can rerun the analysis with these combinations and the loads brought in from Etabs. So we're going to include the lateral reactions, and when I select include lateral reactions, the program lists the 2 lateral load cases that are included from the export from Etabs, and it shows you where the solution stems from. So this solution is from Etabs. We're including all of the reactions relative to this load case in the rerun of this single floor. If I select include load takedown, we could also include the reactions in columns and walls due to load takedown. Because this is not a transfer level, we don't really need to include the lateral the gravity load takedown, because we already have dead and live load applied to the surface of the slab. So we'll go ahead and deselect that, and now I can go ahead and just rerun this particular level with these combinations and these reactions included. We now have the solution for this rerun, and if the intent is to design the floor slab for combined gravity and lateral actions, we could then go in And similar to what we would do with a regular builder model, we would set up support lines and strips along each of the directional frame lines, both in the X and the Y direction, and obtain solutions for the slab design. We'll go ahead and go back to multi-story mode. Another use case for the information that was exported through the integration console is to be able to rerun the analysis for the lateral loads that came from Etabs. If you recall, we imported lateral loads for seismic and wind, and those were stored in this generic lateral load wizard. If you recall, there's a list of those combinations here, or those load cases shown here. And so we're going to set up native load combinations in order to run those particular load cases and story forces that were imported. So I'll go back to loading load combination, and what I'll do is just delete the combinations that were imported just to kind of clean this interface up, and I'm going to add a few new combinations. So we'll go ahead and add these combos, no C1 through no C4, and those particular load combinations will be assigned EQX, EQY, WindX, and WindY. So I'll just set this to 1 times EQX, 1 times EQY, 1 times WindX, and 1 times WindY. We'll say OK. Now that I'm running the model globally, I need to mesh the entire structure. So I'll go ahead and in global mode, I'll mesh all of the levels at once. And we have now a meshed structure inside of Builder. We'll go back to FEM and Analyze. And this is just a warning that tells me there's several patch loads that were defined, but they're not mapped to any of the load combinations. Because I deleted the combinations that were imported from Etabs, those included these dead and live load cases. I got rid of those, so these are now basically orphaned load cases. We can build other combinations to include these, but we'll just go ahead here and select yes. We're going to run the model for no C1 through no C4. Those are the lateral story forces that we imported. We'll go ahead and select OK. We'll select yes to save the solution. Now we've created a native builder solution from the story forces that were imported from Etabs. And if we go ahead and look, for example, at the no C1, this is, I believe, the wind or the EQX load case. We can always look at the actions now. Because we ran this with load combinations, these actions will actually be shown as combination results. And we can make a comparison between the frame reactions in Etabs versus the frame reactions inside of Builder. So for no C1, if I go to column combination moments, and this will be moments about the S, that's the strong direction, we can see that we have moments here shown in our columns relative to the solution native to Builder. And we could also, for EQX, we could look at the global results from a load case standpoint for moments about S. So these are the moments from Etabs. These are the moments related to the rerun inside of Builder. And just picking a couple of values here, you can see this is 46.87, 35.37 in Builder. And if I look at the reactions that were from Etabs, we have 43 and 32. So they're quite close in this case. If you have any questions or would like to access this version of the integration console, please feel free to contact support@adaptsoft.com. Thank you.